Alrighty guys, day 2 of the COVID-19 outbreak. So we're doing online videos. Hopefully you guys, it's a really nice day, so hopefully you get some sunlight, not cooping yourselves up in there. And remember, you're looking at computer screens for a long time, so just adjust your vision. The rule is 20-20-20, right? So 20 minutes you're on the computer screen or your phone, and then you take a break for 20 seconds. You try and stare 20 feet away, and it's supposed to be able to adjust your eyes, help you so that you're not going cross-eyed staring at this blue screen constantly, and that you don't go crazy in isolation. All right, we are on 6.2.7. Which method should I use? Right, so we have been using the 5D process, and again, I want to practice more because it's a really good way to organize your thinking of guessing and checking. Today we'll be practicing writing equations from word problems and solving them using any of the tools you know, right? So we've got the 5D process, we've got tiles, we've got equations, just filling your toolbox of strategies to solve things. So you're developing an efficient set of tools to solve any word problem, and having a variety of methods will allow you to choose the one that makes sense to you and ultimately makes you a more powerful mathematician, right? So the goal is to be able to do all of these methods, but remember, each person is different. That's why we teach multiple methods, and then you pick the one that you like, the one that makes sense to you, and you go with that one, and then you on the side, you're working on the ones that you're struggling with, okay? So 6.2.7 in your notebook on the left-hand side, we've got 6.2.7. That is our section, and 6-128 is going to be our first problem. So Nick tried to use a symbolic method to solve 3x minus 6 equals 27, but he may have made a mistake. His work is shown below, so since we don't have this in our notebook, let's write it down. 3x minus 6 equals 27. What he did was that he added 6 on both sides. There's that 0 pair. And then you're left with 3x, equals 33. All right, I'm going to pause so that you can copy that down. Okay. So it says his work is shown below. If he did make a mistake, on which step did he make the mistake? The first mistake, right? Because what we look at, and when we highlight your assessments, your tests, all I do is I highlight that first error. Then you know you have to fix that one and everything that follows, right? So what was his mistake? If he did not make a mistake, check his solution and write all correct. Cool thing we can do is we can check his solution, and that will tell us if it's all correct or not. So he says that his solution is x equals 11, so I plug it into the original equation, which means 3x minus 6 equals 27. Instead of this x right here, I'm going to plug in my answer. So instead of x, I'm going to put 11. Okay, solving like we do, terms are separated by addition and subtraction symbols. So we do this one first. 3 times 11 would be 33 minus 6. Bring everything down. Then we continue. I've got 33 minus 6. 33 minus 6 is 27. Does 27 equal 27? Yes. That means that this is all correct. Okay. So that's the first one. And remember, when we're looking at errors, usually when solving equations, it's some early on error that we make. Usually it's like a careless mistake, and then everything else just follows because we're working on that problem. Okay, so double check your work, check your answers. Let's go to the next one. 129. Nick represented the equation 3 times the quantity. So times the quantity of 2x plus 4 equals negative 6 on the equation mat at the right. So we look at this right here. This is 2x plus 4, and then we have 3 sets. So I'm going to pause, draw this. You want to draw this image in your notebook with the tiles. Okay. So part A, it says, choose a strategy to solve for X. You may continue to use algebra tiles or use symbol on paper. So I'm going to pause again. Try and solve it the way you do, and then check with me, right? Don't just copy what I write. You guys are amazing at copying notes. The processing is what we're working on, so you have to try this yourself. Okay, I'm going to start with the tiles first, right? So for the tiles, step 1, make any 0 pairs. Or Miss Davidson says, what does she say? She says to make sure that you balance the sides of equations. Okay, balanced sets of anything. We can't do anything. There is no 0 pairs on each side that we can do. What we can do is we can bring all of our unit tiles to one side and all of our x's on the other side. So since I have right here, there's 4, 8, 12, 4, 8, 12, right? Positives here. What I'm going to do to make a 0 pair, and I don't want to, actually I'll draw it. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whatever I do to one side, I have to do to the other side, so okay. Added 12 negatives to both sides. Can I do that? Yes, I can do whatever I want to both sides to keep it balanced. So on the left-hand side, my 12 positives and my 12 negatives, they make 0 pairs. And what I'm left with is right here, I've got 6 x's, right? 1, 2, 3, 4, 5, 6 x's. And that equals on this side, I've got 12 here. And there's 6 more, so this is negative 18. They're negatives. Remember that? Okay, so continuing with my drawing, I'm going to simplify my drawing a little bit. Right, so if I have 6 x's, 6 x's, and all of this equals negative 18, what do I do to find each one? Right? What I'm going to do is I'm going to divide it by 6, right? So divide it by 6 to find what each one equals. If I take negative 18 divided by 6, that means each one is going to be negative 3, right? Okay, so each one is going to equal x equals negative 3. Okay, here we go. The symbols on paper, right? So here we have 3 sets of 2x plus 4 equals negative 6. There are 2 ways to do this, right? So remember, if there are 3 sets of 2x plus 4, right, I can change this into 3 sets of negative 2, right? So that's the first way. Then what I can do is I can take 1 set. So I'm going to say if there's 3 sets on each side, I can remove that. 2x plus 4, just 1 set of 2x plus 4 will equal just 1 set of negative 2. And now I can solve, right? Here, can't do any 0 pairs. Bringing all of my unit tiles to one side. Here is my 0 pair. I am left with 2x equals negative 6. Divide both sides by 2. This is a big 1. X equals negative 3. My answers match. Okay. The other way you can do this is if I distribute. So, where do I do this? If I do 3 sets of 2x plus 4 equals negative 6, I can distribute to everything in my parentheses, right? So you're getting every method right now. I could distribute to everything in my parentheses. Or you can use the area models that we use. 3, 2x plus 4. 3 times 2x is 6x. 3 times 4 is 12. And you can see from the image, that's what they have out there. So 6x plus 12 equals negative 6. Now, same thing again. Bring all your unit tiles to one side. Add negative 12 on both sides. Here's my 0 pair. Bring it down. 6x equals negative 18. Oh, look, that's what we had earlier. Divide both sides by 6 to just get 1x. And this will give you negative 3. So same thing, same solution, right? And this is kind of like checking, because if I solve it 3 different ways and I still get the same answer, then you're way more confident with what your answer is. Okay, that was pretty quick. This is where we pause, we rewind, we rewatch to make sure that we understand it, right? And then checking your answer, we plug it back into the original equation, right? So check. I'm gonna put my check. I don't have that much room. Check. Right. My original equation, 3, 2x plus 4 equals negative 6. Again, substituting in for x. So 3, 2 times negative 3 plus 4 equals negative 6. So everything in the parentheses first, separated by my addition and subtraction signs. 3 times negative 6 plus 4 equals negative 6. Negative 6 plus 4 is negative 2. Bring down that 3. Bring down everything else. 3 times negative 2 is negative 6 equals negative 6. Then you know that your answer is correct. Okay? I'm going to do a separate video for the next couple problems so that it's not too long. You guys can break it up into sections, okay? Thank you.